Hey math fans, we're going to look at the quadratic formula. Let's get started. When it comes to solving quadratic equations, I always give my students a little piece of advice, which is if you can factor it, go ahead and factor it. Looking at this first equation at number 1, I can multiply a times c together, get 28, and immediately I can think of two numbers that will add up to 11x, which would be 7x and 4x, and 7 times 4 is 28. Easily factorable and easily solvable that way. But what if it's not factorable? Well, then I say if a is equal to 1, I say go ahead and try completing the square. We're going to look today at quadratic formula, but I would say completing the square might be a little less time consuming. So if a is equal to 1, try completing the square. Otherwise, if a is not equal to 1, like down here, we have a is equal to 4, you'd have to divide everything by 4, add 3 to both sides to make room for the c value that will complete the square. But I would say just use the quadratic formula. So what is the quadratic formula? Well, once you have determined in standard form what a, b, and c are, it's the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a, all over 2a. And remember, this has to be in standard form. So when it's ax squared plus bx plus c. How did they get the quadratic formula? Well, they actually got it through completing the square. Again, if you do have a value for a that's other than 1, you'd have to divide by it and subtract c over a to make room for that number that will complete the square. Which, remember, we're dividing it by 2. That's where the 2a comes from in the denominator there. Remember, you got to square it and add it to both sides. And then once you have completed the square on the left, do a little bit of simplification, and you get a final answer of that negative b plus or minus b squared minus 4ac all over 2a. So the quadratic formula and completing the square are exactly the same. That's why it gives you the same answer. So let's take a look at this example. I have 3x squared minus 1 equals 9x. And we're going to solve for x. So first move you should always do is set equal to 0. Most of the time the equation will be on the left and the 0 will be on the right, but it doesn't matter as long as it's set equal to 0. Then you establish what is a, what is b, what is c. Write those down. And then very carefully, you're going to substitute those values into the quadratic formula. Again, it's the opposite of b plus or minus square root of b squared minus 4ac all over 2a. So as you can see, I carefully and slowly, I say do this slowly, because I'm going to tell you most of the mistakes that people make are substituting in, and the next few steps here is where most of the mistakes are made. Either people forgetting, like, for example, negative 9 squared. People will accidentally put negative 81, but it's positive 81. What is the opposite of negative 9? Well, it's positive 9. What's negative 4 times 3 times negative 1? It'll be positive 12. So this is where a lot of the mistakes get made. Simplify. And I'm looking at the radical. I don't believe there's any perfect squares in there. Square root of 93, I don't think there's any perfect squares. So if it doesn't simplify, we separate the plus or minuses into two separate expressions. We have 9 plus or minus the square root of 93 all over 6, which if you plug that into your calculator, you get approximately 3.107. And then you have 9 minus the square root of 93 all over 6, and you get approximately negative 0.107. Let's take a look at another example. We have 11m squared minus m equals negative 5, and we're going to solve for m. Again, set equal to 0, first step. Determine a, b, and c, and very slowly and carefully substitute those values into the quadratic formula. So we're going to get the opposite of negative 1. That's going to be positive 1. Negative 1 squared is going to be positive 1. But I see a problem. Do you see the problem inside the radical? What's going to happen? We're going to get negative 219 inside the radical. Okay, that's a problem because you can't take the square root of a negative number and get a real number. It's going to be an imaginary solution here. Both answers will be imaginary. The graph of this particular equation looks like this. Notice how there are no x-intercepts because we can't graph any real x-intercepts. There's only imaginary x-intercepts, and it wouldn't be visible on this graph. Your final answer, if you were to simplify this further by factoring out the I from the radical, would be 1 plus or minus I times the square root of 219 over 22. Two imaginary solutions. So here's the rule. How can you tell if a quadratic equation will have imaginary roots? Well, it's all indicated by the determinant. If the determinant, which is b squared minus 4ac, in other words, the expression that's underneath the radical, if that discriminant is negative, you will have a imaginary, or you will have complex roots. So here are 3 different scenarios for when the discriminant is positive, 0, and negative. Remember, the discriminant is negative b minus 4ac. It's that expression that's underneath the radical. If it is positive, that means you will have 2 real solutions. In this case, the solutions of this graph are negative 1 and negative 5. Those are the x-intercepts, and you can see that on the graph. Now, sometimes you will have a repeated root. In other words, it's actually a perfect square. And notice here it's x minus 1 squared, or in other words, x minus 1 parentheses, x minus 1 parentheses, which you would get the value of x equals 1 as your solution twice. Well, there's not really 2 solutions. It's just one solution, one x-intercept. As you can see from the graph, it has a x-intercept of just 1. And then, of course, if you have a negative discriminant, you're going to have imaginary roots. In other words, no real x-intercepts. And that's going to do it for this section. We'll see you in class.